Hi, Gliderol electronic garage door opener. Now, a viewer called Steve asked if I would have a look at this, and I'll just grab the email that Steve sent me. And he says, "Hi, thanks for replying to my comment. I have a Gliderol garage door opener that would stop working intermittently and show a red light. It wouldn't work again until I turned it on and off at the socket. Then it fully stopped working and now won't turn on at all. I replaced the chip on the advice of a Discord, but it didn't work. I'm a mechanic and have some auto-electrical knowledge, I guess he means, but I don't have enough knowledge on what things should be reading on the board or know how to go about troubleshooting. Would you be interested in looking? Thanks, Stephen." And included in the package are a few little goodies that he sent us as well, so thank you very much for that, Stephen. That's much appreciated. Right, so let's have a look at this then. So it looks like it just unclips at the bottom here. So it looks like we've got a little receiver unit here, microcontroller. That looks like an EEPROM. I'm not sure what that IC is there. We've got a few buttons, and I guess the power supply port's under here. So let's see if that comes off. There we go. Just get that out of the way. Alright, I'll tell you what, let's zoom down a bit. Let's have a look over here. So I guess that must be the IC. I'll just get something to point with. So I guess that must be the IC that Steve replaced. It looks like one of these little offline switcher ICs that I've came across in, I think it was one of the Dyson fans. That looks a very similar pinout. So it looks like the mains comes in just here, goes through a fuse, possibly a little bit filter in there. Comes to the bridge rectifier. We've got one or two possible mains caps there. Through the switching IC, through the transformer. Looks like we've got a couple of diodes there, so it looks like there's more than one output on the supply. And it looks like we've got some more filtering and capacitors here, and then I guess that's the output that goes to the rest of it up here, and possibly a little voltage regulator there. Alright, I'll just zoom back out a little bit. So what I've recently made is one of these dim bulb testers, and what it is a mains lead, comes in here, the live goes through a bulb and then to the live pin of the socket here, then the neutral and the earth goes straight through. And what this is for, if there's a short on here and this is going to blow up like the Starlink router I did recently, then instead of it failing catastrophically, it means the bulb should just light up and hopefully save any electrical components on here. So let's plug it in and let's see what it does. Well, the bulb isn't lighting up. So that means we don't have any shorts, but it isn't actually glowing or anything. So it mustn't be drawing a lot of current. Let's just go on to volts AC, and we'll just check. Let's zoom down a fraction. We'll just check we're getting AC on this bridge rectifier here. And we do 248. So we're getting mains into the bridge rectifier. Let's just see what we'll get on the output of the bridge rectifier. About 339 there. Now let's see if we can find a ground. There's a ground marked here. Let's just try one of these capacitors here, see if we get any voltage. Now I do seem to be getting something there, because on the meter it seems to be flickering between 0 and 0.2. Just try on this. And you can see it a bit better there, so it seems to be rising up to about a volt and then switching off. So that usually means something either on the startup of the IC or possibly a short on the output. Let's say some of these capacitors could have failed, and I have had some of these capacitors fail before. I don't like these type of surface mount electrolytics, these aluminium type. They seem to be quite problematic. I've had a few of these fail in the past, and I think it was on the expensive fire alarm power supply that I looked at that if some of these had failed. Well, that was actually on the startup side. Right, let's just switch this off for now. I'll unplug it, and I might unplug this front panel as well just to get this out of the way. Right, I'm not sure whether to bring the microscope in on this so I can get a bit closer look, because my old eyes are getting a bit short on lamp oil, as me dad used to say. Right, I'll just go and set the microscope up. Right, I've got the microscope set up, and the first thing I've noticed is the soldering doesn't look particularly great on this. I think it's a bit oxidized. Let's just have a look, see if we can see anything else. So there's the IC that Steve replaced. I can't quite see any number on that though. Let's just spin it around. Let's try adjusting the focus a bit. Looks like it's kind of scraped off a bit there. Now he has sent us a little package with some parts in as well. I'll just grab that. And I think he said he included the original chip and some spare replacements as well. So let's see if we can read a number off one of these. So it's an LNK-624D0. He's also sent us some replacement bridge rectifiers and some mains smoothing capacitors. Right, let's try testing a few things then. So let's go on to diode check. And we do have a diode here, so let's see if that's okay. Yeah, that looks okay, because we should get a reading of about 0.5, 0.6 across the diode. Not always. If it's a shocky diode, it's normally a little bit less than that. Could be 0.2 or something, but generally, let's try these ones. Yeah, 0.5. 0.5. Let's just check some of these resistors. We've got a 5, 1 and then 2, 0, so 5.1K. And just about. And we've got 3, 3, 1, which is 3, 3 and 1, 0, so 330 ohm. Close enough. So 2, 5, 5 and 2 zeros. Well, that looks a bit high, that. Let's see what this one is. Can't quite make the number out on that one. Looks like 4531, I think. Let's just zoom down a bit. I mean, we could be measuring other things in the circuit. I'm not sure if somebody's had this out as well. I mean, there's not a lot on the primary side of this. Let's just go along a bit and we'll come back to those diodes. Now I don't know if that's 1B0 or 180. That should be 18 ohms, and it is. So it's 180. I've got a diode here. Let's just try that one. Just go into diode check. Well, that doesn't look right. I mean, there could be something else in the circuit. Let's just check this capacitor. Tell you what, if I go on to resistance here, I'm only getting 1 ohm on that diode. I was just thinking if this capacitor is shorted, it would then affect be linking this 18 ohm resistor across this diode. But it's only measuring 1 ohm. So I think that diode's gone, for a start anyway. But if it has gone, then what's caused it to go? Looks like we've got the same diode again down here, so let's go back onto diode test. Yeah, that's measuring more like it. Like I say, these high-speed Schottky diodes, if I'm pronouncing that right, we're only getting about 0.2 voltage drop. Let's just try that the other way around. And that's just the capacitors or whatever that we're measuring in circuit there. So that one seems okay. I think it's the same number. Looks like GW360. Yeah, I think that one's GW360 as well. Let's try and focus that in. Yeah, GW360. So it's pretty much the same circuit on this side of the board as we have at the top side of the board there, with the 18 ohm resistor and capacitor and diode. Let's see if we can see the number on this one. So that's a 78L05, which is a 5 volt regulator. So the only thing I've found so far is this diode here. Definitely seems to be short. And there's a query over the values of these resistors here. But they may well measure okay if we take them out and measure them. So I think I'll do that. I'll start by taking these resistors out. We'll check those first and then we'll take that diode out. Right, I'm just going to add a bit of flux first. just leave it like that. Right, let's see what that measures then. So 4.53K, so that's actually measuring okay. Let's just pop that back on. Let's just double check this one. I should maybe put a bit of flux on it first, but right. So 25K or 25.5. So that seems good as well. Right, let's put a bit of flux on here first. Right, give that a little bit of a clean up. Get rid of that bit of solder splat there. Right, let's have a look at this diode then. Let's see if we can get that out. I just might have to spin this board round because otherwise I'm going to be working over the top of these capacitors and it's going to be quite hard to get that iron in. So I'll just spin this board around quickly. Right, let's go back on the diode check. And let's see what we get on that. A little bit easier said than done. Probe keeps slipping off. Try the other way. And there we go. Right, so that's definitely short, so we need one of those. Right, I'll have a look around on some of my old boards and I'll see if I've got a suitable replacement for that. One moment please. So I've looked up the specification of this diode and what it seems to be is 3 amp at 60 volts. Now I don't have one of those, but I do have an SS56 which is also a Schottky diode, and this one's rated at 5 amp at 60 volts, so it's rated at slightly more amps. So it can just handle a couple of more amps than what this one can, so it should be fine to put that in here I think. So let's get this put in and then I think we'll check some of the capacitors and that and stuff. So let's get that the right way around because it needs to go in like that. Let's get a bit of flux on there. Right, that should do for that. I'll just give it a bit of a clean up. There we go. So let's check some of these capacitors. Now, the best way to check these is to actually take them out of the circuit. And what we'll do, I'll just try and measure them in circuit to see if we get a rough idea. So I'll try this one. So it looks like we've got 5 of them in parallel there, from the reading that we're getting. Right, I'm just going to see how these are wired up. So we've got a capacitor here, a capacitor here, and a capacitor here that are wired in parallel. This one is the output from the voltage regulator, and then we've got a capacitor here, a capacitor here, and a capacitor here, wired in parallel. Now the symptoms he was having, that it worked and then it gradually got worse, kind of suggests a capacitor problem. So I think I might remove one of these capacitors and we'll just measure one and just see what the actual readings are on it. So I think I might take this one out here. It's closest to the end there, so let's see if we can get that off. And we'll just try it on here. It says about 230 microfarads, so I would say that's okay. We can try it with the component tester just in case there's something wrong with the ESR or whatever, so let's try that. Let's see if we can get that in shot properly. Maybe better just to hold the wires on here. Well, that's not right. Let's just see if we can get the wires on. That's better. Yeah, so I'd say that capacitor seems okay. Right, let's pop that back on then. I'm going to put a little bit of flux on there first, I think. So I think I might touch up some of these joints that look a little bit dry. I've got a one on that diode there, doesn't look the best. Just add a bit fresh solder. I think that bridge rectifier looked a bit not the best, so we'll do that as well. Right, I think we'll go and give it a try now then. I'll just get the microscope out of the way. So that's the diode that I removed. I just want to stick to my finger, that is. And as you can see, definitely shorted. Right, I'll get this out of the way. Let's zoom out a fraction as well. Well, that looks promising. I've got a power light on there and it went beep. Right, I'll just switch that off a sec. I'll just turn it around. Let's get the cover and then we'll try the remote to see if everything works. Right, let's get the mains bit back on, the cover. Let's see if we can figure this remote out now then. Oh, there we go. Oh, well, that did something. Well, I've got no idea what it's supposed to do, but it's clicking and doing things when you press the remote, so I guess that means it's working. Right, nice little fix on that one then. I enjoyed that one. Right then, if you enjoyed it too, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.